Alright, continuing in Fashion Week for chemistry. I say Fashion Week because it's trends, like trendy. Get it? You know, Miss Kirkpatrick actually studied fashion or business fashion or something. I don't know. She's just fabulous. What am I saying? We're all fabulous. As long as we continue to learn from our mistakes, we can all be fabulous. Alright, so within a period. I know a period is a row, so that means side to side. So like that. You know, back and forth. Atomic radius in period 2. So I'm looking at period 2 in my periodic table right now. It goes lithium, beryllium, boron. Yeah, okay. And so I'm noticing here atomic radius is going down as I go to the right in the period. Lithium, wow, is a lot bigger than neon. It's like 4 times as big. That's crazy. But, they all have 2 shells. Okay. Well, okay, so they're getting smaller. Electronegativity in period 2. So now electronegativity is going up as I go. So they're getting smaller. Electronegativity is going up. I know electronegativity is how well an atom attracts electrons. Like if electrons were girls and if I were an atom, I would have a high electronegativity because I attract. Alright, never mind. So ionization energy. So now ionization energy is going. Well, hold on. So lithium is here, neon's here. So if we're going left to right, we're actually going up the graph, right? So first it gets bigger, then smaller, then bigger, a little bit smaller. So in general, ionization energy is going up as we go to the right, just like electronegativity is going up. That's supposed to be a straight line. Sorry. Okay, interesting. You need to pause the video and answer these. So as you move to the right on the periodic table, atoms become, well, that's atomic radius. They attract electrons, Well, attracting electrons, what is that? This makes it to remove an electron. And then do the same thing for to the left, which is the other way. So pause the video and do that. Come on. I told you to pause the video. Seriously? So let's keep reading. Using our knowledge of the atomic nucleus and its surrounding valence shells, I know valence is the outer, we can explain why the trends of atomic radius, electronegativity, and ionization energy look the way they do across a period, which is side to side. In a single period, all the atoms have the same outer shell, right? So these all have 2 shells. But different numbers of electrons, that's true. As you move to the right, more... More what? What page is this? Anyway, let's keep looking at this. So as I'm going to the right, I see that there are more protons, right? So the number of protons is increasing, and I can see this is getting smaller as adding more protons. It has 3 here, then 4, then 5, 6. I don't know if that made it out on your paper, but I can see that on the screen here. Right. Hold on a second, guys. Okay, so don't know what happened there. So more protons, well that's what we just said anyway, are added to the nucleus, because remember protons are in the nucleus, that's why the nucleus is positive, even though no more electron shells are added. So I have more protons, still 2 shells though. Okay, so as we move across, they have more protons, so because of this, the electrons feel more attraction, right? Because lithium has 3 protons pulling on the electrons, neon has 10, so that means there's more electronegativity, because that's the attraction. It's harder to remove electrons. That makes sense, because if they're holding on more, it's going to be harder to take away. And then if they're holding on tighter, they're going to get closer. So the atoms actually get smaller. So it sounds like this actually is going to explain what we just said. So from left to right, the atomic number increases. So more protons, which means the number of protons also increases. Oh, I just said that. As more protons are added, the attraction, right, the electromagnetic force between the nucleus and the outer electrons gets stronger. Since the attraction between them is now stronger, the outer electrons are drawn in. Makes sense. They're pulling them closer, shrinking the atomic radius. So the atomic radius is actually decreases. With the electrons now closer, they feel more attraction. The electronegativity increases. It's also more difficult to remove, which means the ionization energy increases. Take a look at the check for understanding questions that test your understanding. Be ready to discuss those in class.